everybody, welcome back to another video. Today we're going to be talking about what are we talking? Radicals. Yeah, radicals. All right, they're really rad. So what's radical? A radical is this thingy. It's not always a square root. It can be a cube root or a fourth root, whatever. It's a similar thing. I think you guys know this, right? So yeah, we're gonna be doing it, but with algebra. I mean, who's excited, right? Let's do it. So, these might seem really normal at first, but you need to be really careful with these, alright? You want to double check them. And I'm not saying it just to be a stupid teacher or anything. I mean, teachers aren't stupid, but whatever. Yeah, I'm not just saying it for just to say it. I actually mean you really need to check your answers. You'll see why soon. So, let's say we had the square root of a 3x plus 1 equals, by the way, I'm just making these up, so they might not be that cool. Square root of 2x minus 4. Oh yeah. Obviously the easiest thing to do is just square it, get rid of the radical, because no one cares about it. You can't simplify radicals that easily, right? You can't, I mean, you can simplify if the things inside are being multiplied, but otherwise not really. So now we subtract 2x on both sides, yada yada, this is not new, x equals -5. Alright, looks like we did it, right? Let's plug it in. Who's excited? Square root of -16 equals the square root of -16. They might be 4i and ugly and not real, but they're still equal, so we're all good there. Now, let's do the square root of x minus 7, or x squared minus 7. Let's say 2 plus that equals the square root of 8 minus x squared. I know, I'm being rude. You might be wondering, what am I supposed to do with this extra stupid 2? If I square it, I'm gonna get another radical. Just trust me and square it, okay? Don't worry. Everything's gonna be fine. Plus 4 plus 2 root. What do you mean it's gonna be fine? I have another root and I have more ugly stuff. Well, shut up. At least you have 1 root, not 2. Be grateful for what you have. Oh my god. Can't really write. Alright, 8 minus x squared. Okay, so now when you have this kind of stuff, you might have to get rid of the radical in more than one step. So now let's isolate the radical. That's always good. When there's one radical, isolate it. So yeah, isolate it. Let's see. Right, yeah, okay. And that's equal to 2 root x squared minus 7. Hey, it's not isolated. There's a freaking 2 there. Dude, if you square it, it's gonna be fine. There's not gonna be another radical. So if you square this thing, right? You know what? Here's a genius idea. Let's set y equal to x squared. Alright. So now we have 2y minus 11 equals 2 square root of y minus 7. Okay, get to the point. Move on. Okay, cool. Square it. 4y squared minus 44y plus 121 is equal to 4y minus 28. So yeah, if you're multiplying something by a radical, and then it's still basically isolated. So yeah, if you divide it by 2 and then multiply it by 4 at the end, you get the same thing. So yeah, cool beans. Let's subtract it by, yeah, I can't read my handwriting. Cool. So now we can bring everything, once we have a polynomial, we can bring everything to one side, right? 4y squared minus 48y plus 149 equals 0. Alright, y equals 48 plus or minus the square root of ugly. You know what? Let's use a calculator. Totally. I mean, you don't need it, but I mean, who's gonna just do 48 squared on paper? That's so boring. Alright, cool, we got that. Minus, see what I mean? You're not gonna do just freaking 16 times 149. That's kind of a weird thing to do. Oh, looks like we're getting negative roots. Okay, so that all over 8. That's equal to 48 plus or minus the square root of negative 80. I know I'm really generous here. We can simplify that, right? Cool, yeah. 2, no, we can even simplify it even more. 4i times the square root of, what's 80 over 16? 3.125. What did I mess up? If you divide it by 4, you get 20. If you divide... What? What am I doing? What's 80? Wait, what? Okay, so you have the square root of 80. That's the square root of 2 times 2 times 2 times 2. Oh, I can take out a 2, I think. Wait, 2 times 2 times 2 times 2 times 5, right? So I can take out a 4. What the heck? Oh, no, that transfers to a 2. Wait, what? So confused. Okay, my brain isn't working. You can take out a 4i. What did I do wrong? Oh my god. You know what? My brain isn't really working. We're just gonna put the square root of 80 times I, right, all over 8. Cool. Now, guess what, guys? Aren't you excited? Because x squared equals this, right? Let's freaking square root this. So it's the positive negative square root of 48 plus or minus I root 80 over 8. Oh my god, this is not something I'd want to check. Really? So I'm not gonna check it. Let's look for a better problem, right? So, give me 1 second. Alright, so now, forget that example. That was a waste of time. That was just to check if you guys' brains were working. Now we're about to get real serious, alright? Let's say that we had the square root of negative x squared minus 2x plus 1, and that's equal to x plus 1. Alright, we know what to do, right? Obviously, square it. Plus 1. Alright, and then get everything to one side so we can solve it since it's a quadratic and this is algebra 1 now, right? Super easy. Let's factor it. Alright. Yeah, cool. Let's factor it. That means that x equals 0, so and then 2x plus 3, so negative 3/2. Right? Isn't that the answer that you get? Oh, sorry, there's a friggin'... Oh my god. Can't read my handwriting. So now we have, oh my god. Okay. Sorry, yeah, negative 2. Alright, looks like those are answers, right? Let's check it. Remember, check it. Trust me, you're gonna want to do it. Okay, what's the square root? Okay, 0 squared is 0. So that's 0, 0, 1. And that's equal to 0 plus 1. Is that true? That's correct. It's amazing. Let's plug in negative 2. Alright, obviously it's going to be the same thing. Negative 2 squared is 4. Negative 4 plus 4 plus 1. That's equal to negative 2 minus plus 1. That's negative 1, right? Alright, that's 0 and that's 1. So the square root of 1 equals 1. That's obviously correct, right? You're wrong, buddy. Because the square root means a principal square root, right? Not the positive or negative square root. Or not just a negative square root. So the answer is only this. What happened here? This is what you call an extraneous solution. What's an extraneous solution? Well, algebraically it worked out, right? But it didn't really work out in the end. So what happened? Well, you see, when we squared it, right? It's one of those stupid things, right? When you square something, then you're kind of counting, then that's equal to negative x squared, alright? Remember that. So the square root of this squared is the same as the negative square root of that squared. So, like, it could be either one. When you get the squares, it could be either one. You don't know. So, notice that, the square root of x squared is x, and the square root of x squared. Wait, what am I doing? Wait, no, sorry, no. What I meant to do was that, if you had x squared equal to 4, you might say x equals 2, but x can also be equal to negative 2, right? Since when you take the square root, you can take the positive or negative square root. And remember, the principal square root is just a positive one. When we have this, we just mean positive, alright? That's why there's a positive negative in the quadratic formula. We saw the proof of it. We're doing completing the square and stuff. So yeah, so check that video out. So positive and negatives are counted in the squaring. In this case, we get an extraneous solution because we're only counting the positive. If we had negative, let's see what would happen actually if we had the negative square root of negative x squared minus 2x plus 1 equals x plus 1. Alright, let's square it. What do we get? We get the exact same thing, right? Negative x squared minus 2x plus 1 equals x plus 1. These are the same thing. Alright, so this is the big takeaway, the real spice. These both end up going into this. Now, if we solve it and we look at these solutions, right? 0 and negative 2. Let's plug them into this equation, alright? We have this negative square root of 0 minus 0, alright, 1 equals 0 plus 1. And so we have negative 1 equals 1, which is not true. So in this case, what happened was that, oh yeah, and let's do -2 as well, right? So negative square root of -2 squared is 4. So we have -4 plus 1 equals x plus 1. Alright, we have these cancel 1, so you get this negative, oh yeah, x is -2, right? Okay, cool. So now we have the negative square root of 1 equals -1, and that's true. So what happened here? Notice that in this case, with the positive square root, we eliminated this one and we got the first one. And this one, with the negative, we eliminated the first one and got the second one. That's just the logic behind it, alright? If you square this one and you square this one, you get the same thing, right? That's why you need to be careful with these things, and that's why there's a whole video on it. So basically, yeah, just be careful, right? Let's solve one more problem, alright? So let's say, let's make it a bit of an ugly one. Let's solve the cube root of x cubed minus 3x squared plus 2 equals x minus 1. In this sense, we don't square it. We'll cube root it, or we'll cube it. In fact, if you had a cube root equals a square root, you can't do either. So you'll do the least common multiple of them, which is 6. So you do the 6. So you bring them all to the 6, then you get, and you wouldn't have any roots then. So yeah, keep that in mind. If you cube both sides, you get x cubed minus 3x squared plus 2 equals x cubed minus 3x squared plus 3x minus 1. Cool. Guess what? That cube, kind of ugly thing, might have seemed ugly at first, but they do cancel out. That happens a lot of the time. And these kind of radical equations, the maximum degree cancels out. Alright, these also cancel out. Wow. And we're left with 3 equals 3x, so x equals 1. Plug it in. We get the cube root of 1 minus 3 plus 2. That's 0, and that's equal to 0, so it checks out. The reason why this one had only one solution was because everything kind of canceled out. So yeah. Let's say that we had, I know that I said that'll be the last one. Which one did we do earlier? Okay, cool. So now, let's say that we had, this will be the last one, I think. Actually, we'll do one more after this. So now the square root of 2x minus 1, we'll do it fast. 2x minus 1 plus 5 equals 2, or this equals -3, square both sides. 2x minus 1 equals 9, equals 10, so x equals 5, doesn't work. 10 minus 1 is 9, now equals, wait, doesn't work. Oh well. We see that the square root of 10 minus 1, which is, wait, did it work? Oh wait, no. Yeah, that's equal to 9. That's not equal to -3. Oh well, looks like there's no solutions to this. And if you think about it from the beginning, the square root has to be positive. Here we have a negative. So, yeah, obviously it won't work. Always check for these. These extraneous solutions occur more than in just radicals. They occur if you divide by x in a polynomial or anything. Notice that the highest degree, let's say we had 3x to the 9th, if we divide it by x, we get 3x to the 8th. Let's say we add some other polynomial stuff, but let's say that say p1 of x. That's that function, and we have some other stuff here, and that p2 of x equals this one. Notice that p1 of x, let's say that the degree of p1 of x, let's say that's equal to 9, which means this term, and then the degree of p2 of x is equal to 8, which is this term. Then notice that if we divide it by x, we get 3x to the 8th here, and here, oh wait, what am I doing? Sorry, so this is 7 x to the 8th, and we'd get 7x to the 7th here. So notice that if we divide by x, then the degree goes down by 1. And notice that the number of solutions is in a polynomial is a degree of that polynomial. So if you divide it by x, then the degree goes down, so you're losing one root. Notice that. Usually it's 0. But you can't divide by 0 because x equals 0, so you can't divide by x equals 0 because then you're dividing by 0. So yeah, now let's do our last problem, right? Where'd it go? Alright. Let's do this. Last problem. Square root negative 2x plus 30 equals x minus 3. Square both sides. Negative 2x plus 30 equals x squared minus 6x plus 9. We get x squared minus 4x minus 21 equals 0. Right, and then we get x equals, x equals 4 plus or minus the square root of 16 plus 84. This is 100. So this is 10 all over 2. So now that's equal to 7 and negative 3. Let's plug them in. Square root of negative 14 plus 30 is equal to 4. Is that true? This is 16. That works out. Alright. Now negative 3. We have 6 plus 30 is equal to negative 6. That's 36. This is 6. So 6 is not equal to negative 6. So this is not equal to that. So this doesn't work, but this does work. So we plugged in 7 for the first one and negative 3 for the second one. So this one does not work and this one does. Negative 3 is extraneous. So yeah. Cool, thanks for watching. I made this really long. I wanted you guys to get the practice, right? I don't want you to just take my word for it. Many problems have this. Be careful, especially in competitions. So yeah, thanks for watching. Goodbye.